going live this way. Hopefully everyone can find us. All right. So, hi. Welcome to Saturday Science with Miss Steph. Today is April 18th, 2020. All right. And we're here live. I'm going to be doing two activities as usual. You know that we do two activities. We're going to do some electricity, a little bit of electricity, and we're also going to do a water beads activity. Because, as you know, water beads need to develop. Develop. We are going to do the water bead activity first. We're going to start that off first, and then I'll show you the electricity activity. And just a reminder, we're doing electricity the way that we're doing it because it was a request from D. Rose. All right. And so you know who you are, love. All right. Hopefully folks can join us, and we'll go ahead and get the indicator over there. Really sorry, guys. For those of you who know me, I do not like to be late. So I'm not pleased with that, but I guess I'm gonna have to go over there. Such is life. So let's go ahead and launch right in. We are doing two activities today. Like I said, I have some things kind of set up. By now, you should know what this is. If you have been watching any of these episodes, you should know that this is a graduated cylinder. All right. We're going to use our graduated cylinder to measure our water. All right. We're going to measure water. Okay. Also, we have some cups. I've already started a little bit, like kind of a little in advance, our cups over here. I have 3 cups because we're going to be doing 3 different, thank you for joining me. I see 2 people on YouTube and I've got 2 people on Facebook. So I imagine that we'll multiply. Hey, it'll be fabulous. All right. So we're going to do 3 different samples today. We've got water beads that will be with baking soda and 25 milliliters of water. We have water beads that are going to be with shaving cream in 25 milliliters of water, because I've never done water beads and shaving cream. So I was like, that's finally what happens. So, I mean, I use shaving cream for all kinds of other different fun activities. Let's observe, right? And then we're going to do a control. Everyone say control. Not in the Janet Jackson sense of the word control. Yeah, no, not that. I'm talking about your your base level, your thing that you're going to compare the other samples to. That's what a control essentially is in science, right? And so I'm going to label that one. I have the other ones pre-labeled, but of course, going to show you while we're doing this, just in case you decide to do this at home, right? And so there's a couple of things that you can do this with. Water beads are a polymer, and they absorb what? Think about it. It comes from their name. They absorb water. And when they absorb the water, they expand, they get larger. But one of the fun things that I like to do with my students, with you, with my fabulous scientists, hello, around the world now, hello, fabulous man, is put the water beads in different liquids or in water with some type of additive, and observe and find out how those water beads expand. How does the expansion change when you've added something to the water, or when you use a different liquid other than pure water? Why not? It seems like fun. What could you do? And so these are my beads that I have. Like I said, I'm going to label this, and I'm actually using a dry erase marker. I find that that's easiest to label things with dry erase, or a permanent Sharpie if I'm wanting to use it on glass and I want to make sure that it doesn't go away. But if I want it to easily rub off, I just use a dry erase marker. Okay. So here are my water beads, and some of you might not have these at home, and maybe you might want to try this experiment. If you have access to diapers, you essentially have access to the same polymer that's in water beads, or an extremely similar polymer, that same technology. All right. Or if you have some of the stuff that says like fake snow, all those things are similar polymers. Once again, we're doing a water bead activity. We're experimenting. Yes, this is an experiment. It's very close to a controlled experiment. We're going to do a control. We're going to measure. I'm measuring out the amount of water beads. I'm measuring out the amount of liquid that I'm adding in. And so this is one of our more controlled experiments that we're doing. Okay. Sometimes we just do an activity and we're like, let's play, let's mix it all together. But today we do have some measurements, and we're comparing to a control sample, right? And so those are the components that you need for a controlled experiment. You need to have only one thing change, hello, and that's our additive to our water. And then you keep everything else the same. That will give you a controlled experiment. All right, and so our controlled experiment today is water beads. Water beads. So I'm labeling my cup. You know how I do. I got a label. I'm writing beads plus 25 milliliters. Measurement. A measurement is a number and a unit. It's not a measurement if you just put numbers, because no one knows what units you're talking about. Okay? 25 is not a measurement because that doesn't tell me anything. 25 what? 25 tons? 25 microliters? Hello? You understand? You see what I'm saying? All right. So yeah, come on, people. All right, so 25, so beads plus 25 milliliters of water. That's the other thing. What are you measuring? You're measuring like just, salt, 25 pieces of salt, 25 like grams of salt. What are you doing? All right, H2O. Y'all know I prefer to do H2O for water. Alrighty then. So fabulous. Love, 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 love seeing all of you. And yes, hi, hello, and I'm okay. It's good to see you. I'm okay, especially you're on. Yes, hello, thank you. If you're on, I'm good. All right, so let's go ahead and continue. Going to use this measurement device. Once again, if you do not have water beads at home, but you have access to diapers, it might be a little harder to do a controlled experiment with the diapers, but you can still kind of like play with it a little bit, right? You can cut open a diaper and throw some diaper, what we used to call diaper fluff, for those of my students who remember summer science club circa like 2012, 2013, 2014. We used to do, instead of water beads, before I smartened up and ordered water beads, I used to cut open diapers. Hold up, backstory, old school summer science club stuff. All right, so yeah, so you can do this activity with whatnot. Okay, fabulous. Cool, cool, cool. Do, do, do. All right, so we're here. Yes, so we've got this. And grab my water beads inside. Now, the next thing that I need to do is add my additive. Baking soda. I hope that everyone is able to find us on YouTube. So I'm saying this now, not necessarily for YouTube, but saying this for Facebook. Can you guys kind of help us share a little bit? We're just kind of help let people know, everybody in our science club community, let them know that the YouTube link that I sent out previously didn't quite work. So we switched things up a little bit. Okay. And so tell people they can still get on my YouTube page, my YouTube channel, and just go on the new live link. But of course, if you're already watching on Facebook, hey, just stay there. Good. All right. Especially on Facebook, you can send me comments and I'm looking at them. Hello. Hey, Monty, Adrian, you're here. It's nice to see you. All right. So what's this? One of my other favorite, right? So I've got baking soda. It's a little bit of baking soda. All right. How you doing, here? Nice to see you, honey. All right, and so see, we're just doing a little bit because I actually just want to affect my solution ever so slightly. All right. So now You noticed how I put the same amount of water beads inside of each cup. I labeled them, and now I'm going to go ahead and move on to the water. And as I'm moving on and measuring my water, I just want to give a quick reminder. We are doing 2 activities, okay? We are doing 2 activities, and we do have, what am I trying to say? And we are, yes, my person who requested the electricity with the Play-Doh, please, please, please know that we are going to do that. All right. So we're pouring 25 milliliters of liquid. Okay. And I'm going to add the 25 milliliters into each thing. Boom. Right. Notice I'm getting down low. Right. Going up to my thing. All right. You see, using my graduated cylinder, and I'm pouring over the shaving cream because I want the shaving cream to mix in. Obviously, I'm not going to stir. So what I'm doing is pouring. All right. And then I've got here. Uh-oh. Did we get kicked off for a second? I hope we're still on. All right. Oop, that's a little bit too much. Yep, that's fine. All right. And then now I'm adding here. Okay. So I'll swirl it. But other than swirl, I'm not doing much else other than swirl. So we'll check this out. Okay. At the end, we're going to check this out at the end. So I'm going to ask you all to bear with me. I have folks that are contacting me that are wondering what happened because we had to change links. Okay. So Facebook, you're going to move around with me a little bit. Uh-oh. 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 Okay. Stay with me, Facebook. Stay with me. Okay. So, are you still there? Are you still there? Please check. Hi. Hi. All right. So, thank you. Thank you. Thank you. Thank you. Thank you for staying with me, guys. I am, we got Kelly Lewis. Hey, Kelly. It's good to see you, hon. Thank you. All right. So, thank you all for being patient. I am obviously doing a lot, so you can tell that I wanted to just communicate really quick with someone who sent me a text and wanted to make sure that we were still on. Okay, so yes, we're still doing this, folks. Fabulous. So like I said, over here we have our samples. I'm going to show you some samples that I started later. My apologies, that I started yesterday, and also the samples at the end of our time together, the samples that I started today in class. So now let's go ahead and move on to our, I had everything perfectly balanced. All right, move on to our electricity activity. All right, so first of all, what is electricity? You people know? Do you remember? I talked about this. This activity is an oldie but goodie, and I've actually did a quick little pop-up with this as our theme a couple of weeks ago. All right. Somebody in the comments, on Facebook comments, what is the really baseline definition of electricity? I'm waiting. I'm waiting. No, you don't know? All right. So electricity is the flow of electrons. I know it sounds very simple and like it sounds almost like you're defining something by its name, but technically it's not. All right. So the flow of electrons. Electrons are very, very small particles. Electrons are actually part of atoms. Okay. And atoms are even smaller than molecules. Atoms are the base building blocks for a molecule. Okay, and so there are certain atoms, right, that are able to have their electrons be free and be able to move around. Okay, and so I know my physical chemistry people are probably like mad at me right now, but just work with me. I work with kids. Come on, guys. This is a definition that works. Okay, so just work with me. Electricity is the flow of electrons, and electrons can flow along certain types of metals and so forth, right? And sometimes electricity is prohibited, right? The flow is stopped by what we call insulators, and the flow is encouraged and moved by what we call conductors. Okay? This information is going to be important later for what we're doing. So just watch me. Okay. So we're going to do a little activity. It's fun. It's really, frankly, very fun to use Play-Doh because Play-Doh, you will find out later, is one of the two. It's an insulator or it's a conductor. You should be able to tell me by the end of this lesson whether it's an insulator or a conductor. Oh, we got more people coming on and joining us. Okay. So, all right. It's great to see you all. Thank you for joining us. Okay. Now, Play-Doh. Okay. Regular store-bought Play-Doh. Yes, you can make it as long as you have certain kind of components and do this. But I'm just going to put, and this is a request. You know who you are, my beloved. This is a requested activity. All right. And keep in mind, folks, you can request activities for next Saturday as well. You never know. Okay. If I've got it within the cabinets, people, we'll do it. Okay. The beauty of having cabinets full of science, fun, goodness right here in my home. All right. So I'm going to place my pieces of Play-Doh separately. I don't want them touching because if they touch, the electricity is actually going to flow through the Play-Doh and not into the thing we're trying to power. All right. And the particular thing you're trying to power is, oh, we've got somebody else on YouTube. Hi. Hopefully you're the person that I text. I hope that you were able to get on and join us. Okay. Oh, thanks, love. Yeah. So we don't want it to short circuit. We want it to power the load. Ooh, yes, Hunty. You did not know that I was going to come on a Saturday and give you all these science terminologies. Yes, this is what we do. Okay. Yes, science is fun. Ooh, ooh, but I still want you to know the true science behind it. Okay. The proper terminology behind it. All right. Uh-oh. I'm gonna have to grab into the cabinets to make sure that my wires are properly exposed, because if they're not, we're not going to be able to do what we want to do. All right, so let's try this. All right, so I've got my alligator clips, okay, and they are connected. Yes, this is a DIY kind of little situation, okay? This is wire inside of a alligator clip, okay? And you'll see that the alligator clips have metal on them, okay? So you can presume that these are conductors, right? And remember, by the end of our activity, you should be able to tell me whether or not the Play-Doh is a conductor or an insulator. I gave you a hint earlier. All right, so let's do this. Let's do this. Anything happen? Of course not, because like there's no lights on, there's no fan moving. All right, I'm gonna move my Play-Doh back here so that you can see Facebook. All right, so I've got various batteries here. One of these batteries better work, that's all I gotta say. All right, got this, clipping. Okay. I've got my lights over here. Once again, yes, I do have all of, some of you may be wondering, does she really have all this stuff in her apartment? Like you, some of you have been watching the videos, you're like, yes, yes. Okay. Science Club lives here. All right. So I'm going to make sure that I've got my short, that I know which one is my short end. That is important. That is very, very important. All right. Let's see if I can kind of move these together. Let's see if oh, what? Come on, somebody. Yes, at something years old. No. I always tell my kids how old I am. At 41 years old, this with my biochemistry degree, yes, this is still cool to me. I love this. This stuff is the best. Okay? This is what you get to do when you go into the sciences. This is cool. Now, all right. Who wants to see if we can make more work? I do. I have, well, YouTube can see. Let me make sure you can see. Yes, Facebook, look. A whole entire container of these. I think we should do the blue one. Now, remember how I just told you a few seconds ago, or a minute, or whatever, however long ago it was. All right. We've got, see, we have the shorter ends. Electricity is directional. So you need to make sure, okay, this is why you have like, when you have things that when they get plugged in and all that kind of stuff, this is why you need to know what direction your wires are going in. Okay, this is the kind of thing like on like a basic level why I do this activity. Yes, it seems really simple and it's Play-Doh and it's fun and all that kind of stuff, but this activity, this lets you guys really see the importance of directionality for electricity. It also lets you be able to see whether or not your circuit is complete very quickly. All right. And also whether or not your batteries work, all that type of stuff. These are things we get to know when we do Science Club with Miss Steph. Yes, Science Club is still happening, people. It's still happening. All right. Join us every Saturday. Hello. Saturday at 2:30 live on YouTube. Whether or not my links work or not, we're still, just so you know, for future. Okay. If I send a YouTube link out and it doesn't work, I'm still going to go on and I'll just open a new one. Okay. So just make sure that you check the channel. Okay. Saturday, 2:30 Eastern Standard Time, every Saturday. Okay. Ooh, 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 ooh. All right. So now let's do red. And yes, I do have a thing with red and blue because red and blue make what color? Who knows? Who knows my favorite color? All right. Red and blue are primary colors. Yes, and that is science as well. The way that light reflects or does not reflect and all that kind of stuff does make a difference as far as the color that we see with our eyes. Okay. All right. So we have, right? What Al Purple Kelly knows. She knows. She knows. She knows what time it is. All right. So we have three of our lights. And I just want to review and make it clear so that you understand the negative end, right? The electrons are coming from here, and going back. That is a circuit. Think circle, okay? And if something is disconnected, it turns off. That's how that works. All right. So if you have, and look, I can be very close. I can be really close, but if it's not all the way touching and connected, you have what's called an open circuit. Okay. And an open circuit means that you have some type of gap. It could be this big, or it could be a micrometer. It doesn't matter. If you have any type of small gap in your circuit, that means that you're not going to turn on the load, as in the thing that you're trying to power will not be working. Okay? Oh, yay! I'm so glad that you guys came on. All right, you found us. All right, so before we go, we need to kind of do our recap, right? Hello, because I'm very into review. Y'all know I was raised by two people that were in the service, okay? And so I'm very into review and being organized and all that type of stuff. We did 2 activities today. How many activities today? We had a great time, okay? At least I had fun. I don't know if y'all had fun, but I had a lot of fun, Okay. For those of you wanting to try to attempt these things at home, I want to make sure you're aware of the materials that I use. Now, the stuff for the electricity is a little harder to kind of work out. But just so you're aware, I have some LEDs, light emitting diodes. So if I say LED light, it's a little redundant, but it's a thing. It's usually what we call them. Our little LED, our LEDs and BT dubs. They are the same type of light that they look like Christmas lights because like that's what's on the little Christmas light chain. All right. So we have our LEDs. That's one of the materials we have. Play-Doh. Yes, this is Play-Doh that I just like bought somewhere. This is not some special whatever. Oh, science teacher material. No, this is Play-Doh. Okay. Once again, let's try one more. I've got my short end. Let's see if this works, right? Let's see the capacity. Another vocabulary word. The capacity of our circuit. The capacity of our battery, right? How much can our battery power? And that would be tested by adding additional loads, adding additional lights to our circuit. All right. And then I have, so let's review, right? You saw that little flicker. Okay. Because I'm moving, I'm disconnecting things a little bit. I'm changing my circuit from being a complete circuit to an open circuit. Right. Remember, if I take anything off, that makes it open circuit. Okay. So I have the LEDs. I've got Play-Doh. I have these wires. This typically tends to be the easiest kind of thing to do. I'm touching these. It's not hot right now, but if I were to leave this in here, the battery would heat up a bit and it would be kind of a little warm. Okay. So you definitely don't necessarily want to have your kids do this activity quite like by themselves. Yeah, you definitely want to be there with them. So we've got wires with our alligator clips. We're going to do a quick dismantle because as engineers and scientists, we need to know how to take things apart as well. So again, to review the things that you would need if you want to try to do this at home, and I can send you like an Amazon shopping list if you're interested or whatever. And I can, send you materials list should you want to try this at home, right? I've got my LEDs. I've got my just regular old Play-Doh. That's in my squish shop. Okay, this is great for my tactile learners who need a little kind of squeezing kind of to smash things, right? To help them learn and experience things, LEDs. Then I've got, this is a 9-volt battery, right? Your 9-volt battery is going to be easiest to connect with your alligator clips. And I'm putting that, and yes, they're Amazon. I mean, I'm not trying to push or not push Amazon in any way. It's just the easiest place for me to order materials even before this whole be at home situation. Okay, I'm gonna put my alligator clips and insulated wires back into my very fancy container. Yes, this is a Party City little baggie. For those of you who have just joined the Science Club community, you may not know that before we were invited to be at home, I actually was traveling around to 10 different locations a week, and so this is how I would carry my materials. All right, so I've got that. So you would need a battery, your wires, your lights, and your Play-Doh. Those are the things that you need for that activity. All right, so let's look at our water beans. So there's a little something that I'm able to see here. This sample is my baking soda sample. Now, typically, baking soda and vinegar definitely has a very violent, very bubbly reaction, but little do people ever observe or notice water and baking soda has a little bit of a fizz too. All right, and so that's what I moved for. Because again, this stuff is still fun for me. Okay. Yes. So we've got our 3 samples. Let's look at the ones that I made yesterday. Okay. And I put these yesterday on my lab bench, also known as this table here, in the annex, also known as my living room. Okay, so this is my shaving cream sample from yesterday. You'll notice that the shaving cream sample, the beads are not uniform, right? They didn't absorb the water in a uniform way because, and I know there's one last little hanging question from our LED light thing, and so I'll do that before we go, by the way. I haven't forgotten about it, guys. And so we've got our samples here. Once again, with this activity, to try to do this at home if you don't have water beads, and yes, you can just order water beads or Orbeez or whatnot online, or from like Amazon or Michael's or whatever. If you don't have those, you could break open a diaper. Kid you not. Same chemical, same little beads. Okay, break open a diaper and kind of try this. Okay, it's a little harder to make it a controlled experiment, like I was telling you earlier, but it's still a thing that you could do. All right, and so this is our baking soda sample from yesterday and our baking soda from today. And then we've got our water. Now, I always kind of tell these kids, when you're thinking about how things work or your different hints, right, your clues, they're called water beads. So the thing that they're going to absorb the best, the most efficiently, the most quickly, would be exactly water. I know you're thinking it because y'all are paying attention and you're awesome scientists, right? So in just that little bit of time, when we've been sitting here together, this is the sample from today. You're not. These are today's samples. This is just from like barely 20 minutes ago, right? Okay. So these are here. These are the samples from yesterday, right? And so that was just a fun little something that I wanted to try and show you what it would be like to put water beads in different liquids, right? When we're doing controlled experiments, the point is to learn and compare. For it to be a controlled experiment, you have to have a control, you have to measure things, and you need to compare just one change, right? You notice we added 25 milliliters of water in all 3 cups. We've labeled them. I added the same amount of water beads to all of the cups because it's not a controlled experiment when you're just going about your business to changing everything and not labeling things and not like measuring things. Not controlled. No, it's an investigation and it's fun. What? Oh, but it's not controlled experiment. All right, so a couple of little pieces of business before we leave. Y'all are supposed to be telling me whether or not the Play-Doh is what the Play-Doh is. That's your homework. Well, not your homework. That's your was that your exit ticket? That's what we call it, our exit ticket. Okay. Before you leave, my folks on Facebook, you all need to you need to leave your comment. Is the Play-Doh an insulator, as in something that stops the electricity? Okay. Or is it a conductor, something that conducts electricity, something that helps the electricity flow? Okay, she is giving me the business, the phone. I'm just have to hold her. That's all right. All right. So, yeah, tell me. Conductor. Is the Play-Doh a conductor? Did the Play-Doh help the electricity flow? Did the light turn on? Or did the Play-Doh insulate the electricity, as in stop the electricity, as in the light turned off when we put it inside? Right? You should be able to tell me that. That's your exit ticket. Make sure I don't see y'all commenting. Y'all supposed to be leaving comments. All right. So it's been fun. Thank you so much for joining me. I'll see you right here. Same bad time. Yes, I'm that goofy. Ooh, somebody's got it. Yes. Go, Lana. Thank you, baby. Good job, baby. Okay. So I'll see you right here. Yes, I did. Yes, I am geeky and nerdy, and I did have the nerve to say same bad channel. Yes, that happened. And I have no shame. Okay. Same bad channel. We're going to be here live on YouTube and Facebook simultaneously. Once again, if I send out, always just know that you can trust to find one of the links on at least on the YouTube channel. Okay, so look through that, and we'll also be live via Facebook. Thank you so much for joining me. I'll see y'all next time. Please, 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 please send me a message if you need some help with your kids' science homework, or if you're interested in getting them involved in something a little bit more engaging. Okay, I can absolutely help with that. Until next time, guys.